Good afternoon, good morning, and good evening. Thank you for coming. Hold on a second. I'll be right back. Sorry about that. Had to fix something. Anyway, yeah. So what I decided to do is spend about 15 hours this weekend. Oh my God, my wife's gonna kill me. To work on these things. Now, what I've done so far is I've made up 2.5, maybe 3 of these. I might get to 4. I'm not sure. I'm going to try to post them on the website. I'm going to post them eventually. They're not there right now, but if you click on New York State Teachers and Review, and you go, it'll be down here at the bottom under Review Topics. And I'm going to call these Final Week Reviews. I'm going to put them probably down right here someplace, in this area, Final Week Reviews. And hopefully you can download them and try them. I would try the problems, certainly try the problems on your own first, okay? All right, so let's get going. Woo, we got some work to do on this sucker. Wait, let me just drink my coffee first. This one's going to be one long video. There is 11 pages and it's 40 questions. Holy mackerel. It took me like 5 or 6 hours just to create this one. So anyway, when you divide, you know if you have the bases the same, you subtract the exponent. So what we're really doing is subtracting negative 5 over 3 minus 2 over 3. And I get negative 7 over 3. So this whole thing becomes w to the negative 7 over 3 raised to the 6 sevenths. Now, if you remember correctly, when you have an exponent raised to an exponent, you multiply these exponents. So the 7s cancel. 3 goes into 6 twice, but notice you just don't forget about this negative, so this all becomes w to the negative 2. Now we know if you have a negative exponent, that makes things kind of reciprocates things, turns this thing, flips it upside down. Remember, this is really w over 1, so I'll take it down here. So this is really 1 over w squared. Now again, one of the things I would suggest you do is you take a number like 3.25, store it into x, or store it into w, type this in, verify they're equal. Moving on. The number of times a student says the word like I was totally doing this like problem, and it was like totally normally distributed with like a mean of 1605, and it had a standard deviation of like 55, And then I was saying to myself, I wonder how many other kids say the word like between 17 and 1800 times a day. Stop saying the word like. You can't like something that much. Anyway, so I drew this normal distribution curve. By the way, I'm going to just keep coming back to the word like because it just sounds like fun. And I'll write 1605 here with a standard deviation of 55. And I want between 1700 and 1800. So, pop on over to the normal CDF. Go over to my calculator. Go right to my calculator mode. Go into menu, 5, 5, 2. I don't know what it is on the other calculators, but it's definitely doable. The low end is 1700. The high end is 1800. And I say 1605 on average. And I don't have the right standard deviation. The right standard deviation is not 5, it is 55. 5 would be really bad. All right, click OK. 0.0148. So 0.0418. 6. Now what do they say to round to? Didn't really say round. Probably should have said to round to because we want this answer. Because this one's not quite rounded correctly. That's why it's not right. Alright kids, let's move on. What transformation maps this into this? Well, you first see this negative to a no negative, so that means we have a reflection, but they all have that in there, so that's kind of boring. We have a plain old x, and now we have an x plus 4 on the inside. Whether it's on the inside of parentheses, on the inside of a radical, or on the inside of absolute value vars, it's still on the inside, and these are backwards. So we're really moving left 4, so not the right answer, not the right answer. And then this is just normal, down 6. There's your right answer. The big winner. All right, kids, what are we going to do with this thing? I think maybe what I would do is just give everybody the exponent. So this would be 32 to the negative 2/5. This would be x. Now 10 is an exponent, and that's an exponent, so I have to multiply them. So that would be negative 20 over 5, which would be negative 4. y to the negative 30 over 5, which would be negative 6. Now, since they're all negatives, they all have to come to the denominator. So this answer can't be right. And if I'm guessing correctly, because all the answers have 4 in them, that's 4. So it's going to be 1 over 4. This comes down, becomes x to the positive 4. This comes down, becomes y to the positive 6. And there we go. Hopefully that's one of the answers. Oh, this was a 2. The answer is 4. It definitely has a 4 in it. Has nothing to do with being negative. All right, let me pause for a second. I'll be right back. Alrighty now. Let's say I just turned 16 and my daddy loves me so much that he bought me a black Jeep Wrangler. I love my daddy. My daddy didn't get me one of them. I still love him. He could have gotten me one of those. All right, I can't even afford one of these, but whatever. Here we go. T months of ownership. So clearly my car started out, remember this is always the principal or starting amount. The value of the Jeep when it was purchased was $50,000. Whoa, why am I crossing that off? Because of course they asked the word not. Man, D&D, you're doing your business. Good job. Okay, so normally what a kid would think was, oh look, this is 0.61. It's losing 60. It's keeping 61%, so it's losing 39%. So that might be the answer. I could probably figure out the Jeep after 1 year. So let's plug all this stuff in our calculator. 50 grand. Parenthesis 0.61 parenthesis raised to the, now it's n over 12, so let's do 1 year, which would be 12 divided by 12. I probably could have just put 1 in there. After 1 year, oh, I forgot a number. After 1 year, it's worth $30,500. Yep. So it's either got to be this one, which is probably the answer, or this one, which might be the sneaky answer. So we got to figure out what it's going to be after 1 month, not after 2 months. Let's see after 1 month. After 1 month, it's worth $47,982.27. Well, did that lose 39%? Did it lose almost half its value in 1 month? That would be stupid, right? Lose half its value in 1 month. This answer makes no sense whatsoever. Don't be tricked. If you divide by 50,000, you're going to get about 0.96, which is the right answer. Tricky question. Don't fall for it. Another tricky question. So normally if the base is between 1 and 0, like 1/3, and we raise it to an exponent, this would be decay. So long as your base is between 0 and 1. But not so much in this case. Tricky. These two definitely have bases that are bigger than 1. So these are definitely growth. But here's one that's 0.8. So I'm thinking, well, that might be the one that is it. But this one has this weird negative. And I cannot stress this enough, kids. Negatives are going to kick your beep. Okay. I didn't get much sleep last night, so this video is going to get weirder and weirder and like weirder. So what I'm going to do is I'm going to go graph these just to make sure. Now, if you don't think I know what the answer is, I know what the answer is. I wrote the question, but I want you to know. So we'll do 0.8 raised to the what? Negative x. Negative x. Ooh, wait a second. That's growth. That's growth. Well, then this must be the right answer, but it's got a base that's bigger than 1. So it can't be the right answer, or could it? Let's press tab, parentheses, 3. I don't know why I didn't put the last one in parentheses. Parentheses, raised to the negative 2x. Oh, that's decay. See, what happens is this negative really takes this base and makes it 1/3 to the positive 2x. That's why you got to be really, really careful. This one becomes 1 over 0.8. Well, 1 over 0.8 is actually a number bigger than 1. I suggest you graph everything. Graph, like and totally. All right, let's move on. Hold on, somebody's calling me. Oh, nope, alarm went off. That was some jazzy music. Hold on, are you still there? I apologize, I didn't get the chance to pause it. Let's move. So, yeah. So, we got to go back to all students take calculus. All students take calculus. So what this represents is where everything's positive. All things are positive here. Sine is positive here. Tangent is positive here. And cosine is positive here. Then you need to know the reciprocal functions. You need to know which ones go with which. All doesn't matter. Everything's positive. If you're in quadrant 1, all things matter. If you're in quadrant 2, cosecant and sine are positive because these are reciprocal functions. Cotangent and tangent are positive down here, and cosine and secant are positive over here. Get my flashcards and start studying. This is important stuff. So, this is not telling us that cosecant is negative 2/5. This is telling you that sine is negative, because sine and cosecant are reciprocal functions, so sine is negative. So I'm going to come over here. Sine is positive up on the top up here, so sine must be negative here, and sine must be negative here. Now I'm going to go to this. This does not mean cotangent is less than 0. What it means is tangent is negative. It really means cotangent is negative, but if cotangent's negative and you flip it, tangent's negative. So it really tells you where tangent is negative. Well, tangent is positive in the first and down here in the third quadrant. So I need to find out where tangent is negative, and that's in this quadrant and this quadrant. The double star winner is choice 4. Like totally. Mr. and Mrs. Harris, that's such a cute couple. We're playing a carnival game. The game had 400 bottles. Oh, this is a tricky question. I think this is a tricky question. 400 bottles, and the participants had to throw rings around the neck of the bottle. The sign said that all bottles were winners. And there were 280 bottles with a small prize. So the probability of a small prize win is 280 over 400. Leave it as 400, it's fine. The probability of 100 with large prize, so the probability of large prize would be 100 over 400. And the probability of large and small, that's why this is going to be hard, is 20 over 400. Now, and just means both, right? So, what is the probability that Miss Harris wins the prizes given that it was a large prize? Well, since it was a large prize, how many large prize bottles were there? There were 100 with large prize bottles. So I know that my denominator has to be 100. Now, of those 100 bottles, which one also had a small prize winner in it? Well, that would be the problem of this, 20. So 20 over 100, which is 1/5. Tricky question. Find the fifth term of the recursive sequence. Now remember, recursion just means you're going to do something with the previous term. So you always start out with a sub 1, negative 5. A sub 2, right? So n equals 2 here is equal to negative 2 times the previous term minus 2 squared. Now why 2 squared? Well, because n is 2. So minus 5. So this is positive 10 minus 4 is 6. Now a sub 3 is going to equal negative 2. Negative 2 times 6 minus 3 squared, because notice now n is 3. Don't go fall victim to thinking you're going to use 2 every time. So that's negative 12 minus 9. I believe that's negative 21. And we got 4. Gosh, blessed. Fourth term equals negative 2 times negative 21 minus 4 squared. That's 42 minus 16. I'm going to grab the calculator to make sure we're doing this right. Negative 2 times negative 21 minus 16. 26. And so finally we get a sub 5 is equal to negative 2 times 26 minus 5 squared. So take this, we're going to multiply by negative 2, and we're going to subtract 25 or 5 squared. Negative 77. Whew. It's always fun when you get the right answer. Yay, I get the right answer. The probability of pizza is 0.3. Oh, pizza. The probability of party given pizza is 0.6. The probability of pizza given a party is 0.25. Then what is the probability of pizza and party? Well, I'm looking for two things. I'm looking for an or, which I don't have, and I'm also looking for independent, which I don't have. So because I don't have or and because I don't have independent, I have to use one of these two formulas. The probability of pizza and party. Now, because they're not independent, I got to assume they are dependent. So I use this formula. Probability of pizza and party is equal to the probability of pizza times the probability of party. Now, wait a second. That's the independent formula. That's independent. So what you do is you keep going. Given pizza, you add the little extra to make it the dependent formula. Or the probability of pizza and party is equal to the probability of party times the probability of pizza. Again, that's the independent formula. Keep going, given party. Now, let's highlight all the things. I'm going to put a big black dot next to all the ones I have. I have pizza given party. Pizza given party. I have that. I have party given pizza. Party given pizza. I have that. I have probability of pizza. That. Now, which equation do you think we should use? Yeah, we're going to use that red one. So let's get rid of the blue one. I know we wrote it, but we don't need it anymore. And that pen is way too fat. So, this is equal to 0.3. And this is equal to, which one is it? Party given pizza, 0.6. And 0.3 times 0.6 is 0.18. Yay! Oh, some more probability. It's not all probability. All right. Oh, this is almost the same question. Miles, A is Miles shows up every day. B is Miles gets an 85 on the algebra or above on the Algebra 2 Regents Exam. So I didn't say they're independent. I didn't ask for an and. So we got to go back to that same formula. Probability of A and B. Now I want the probability of B given A. So remember, it's going to be the probability of A times the probability of B. That will be the independent formula given A. So that's the one I want. So I'm going to write this as probability of A times the probability of B given A. Again, check it out. Independent formula is right here. That's the independent formula. Right? If you add this little piece on the end, that makes it dependent. All right, let's move. 0.2 is equal to probability of A is 0.3 times probability of B given A. And if you divide by 0.3, you get 0.6666666666, which is 0.67. Again, this was just superfluous extra information trying to trick you. Oh my God, more. All right, did you notice this? Alert, alert, alert. We have an or. We have an or. Any time you have an or, you have to write the or formula. Write the or formula. If you don't have these formulas, get them down and get them memorized. They're not going to be given to you. It is equal to the probability of A plus the probability of B minus the probability of A and B. All right, let's figure it out. Probability of N. Oh, probably should be using A and B. Probably should be using M and N. M, N, M, and N. All right, let's put all the stuff we know. We know the probability of N is 0.3. What are you talking about? That's it. That's all you know. Or is it? Did Mr. Krause screw up? Or are you stumped? Das ist die Frage für heute. That's the question for today. A little German for you. Throw a little German down at you. Yeah. I was like doing a little German with you. Okay. Guys, and girls, and everybody else, please remember, independent. I don't care who you are watching. Independent. Independent tells you a buttload of stuff. It tells you that the probability of M is equal to the probability of M given N. It tells you the probability of N is equal to the probability of N given M. It tells you the probability of M and N. Yes, I know I wrote man. Every time I write and, I write it as an A. I don't know, it's like a bad habit I'm into. Is equal to the probability of M times the probability of M. N. Man, this one statement told me all this stuff. Well, a couple of these are pretty important. This one's pretty important. that means that probability of M is just 0.55. Oh, okay, I can put that in there, 0.55. And wait a second, the probability of M and N, which is this piece right here, is really just 0.35. Oh, excuse me, 0.3 times 0.55. So this I got to do my calculator. 0.55 plus 0.3 minus 0.55 times 0.3. Boom, 0.685. The winner. Wow, we're almost 1/3 of the way through this. And I'm almost 1/3 of the way through my coffee. Sorry, kids. And all you complain about that I drink too much coffee. I'm pretty sure if I didn't, I'd be sleeping because I was up till 1 o'clock making this stuff. Actually, I was up till 1 o'clock working on the third day of this stuff. All right, what does this mean right here? What does this mean right here? You have to know what that means. You have to be able to tell me what that means as if I'm talking to my mother that's never seen an arrow before. So call your mom in. Yeah, come on, Mom. Come on, Mom. No, you think I'm kidding? If your mom's not watching, I'm not going on. Call your mom in. I'm waiting. Hi, Mom. How are you? I'm Mr. Krause. Thanks for coming to the party. So she's going to explain, or he, your son or daughter, is going to explain to you what that means as if you are a moron. No, and I didn't call you a moron. You're a really good person. All right, I know. You think that your kid's watching somebody that's probably a bad influence. Maybe. If they said to you, as X goes to the right, Y goes up. Or in other words, wait, maybe you don't understand X and Y. So if they said to you, wait, this not up, that would be wrong. Go down. If they said to you, as the graph goes to the right, it goes down. And as the graph goes to the... Okay, kids. I got to stop with the fun stuff and just concentrate. This says, as X goes to the left, or as the graph goes to the left, the graph goes down. Well, that one works. As F goes to the left, the graph goes down? Nope. As X goes to the left, graph goes down? Nope. As X goes to the left, the graph goes down? Yes. So we have two possibilities. Now it says, as X goes to the right, or as the graph goes to the right, the graph goes down. Graph goes to the right. Is it going down? There it is, the big winner. Mom and Dad, I hope you enjoyed your little lesson on end behavior of a polynomial. Now, go away. Go. No, really go. No, I'm actually not crazy. Too much. All right. According to quick intercept search of a mean weight of a Chihuahua is 3.08 kilograms. My sister has a 4-pound I told you I was up to 1. My sister has a 4-pound Chihuahua. Yeah, it's about the size of a large rat. Kind of looks like one too. And a standard deviation of 550 grams. Alert! Alert! Did you see it, kids? Did you see it? Kilograms and grams. Don't fall victim to different units. I had a really good word that just didn't come out. Anyway, Miss Antonini does not feed her Chihuahua properly and was scolded by the doctor for her really overweight doggy. Her dog weighed 4.3 kilograms. In what percentile ranking is this dog? Rounded to the nearest 100th of a percent. Okay, so let's talk about a chubby Chihuahua. So, 3.08 kilograms. Now, you need to know I can multiply by 1,000 and get grams. So, 3,080 grams with a standard deviation of 550 grams. Now, her big chubby Chihuahua is up here at 4,300 grams. And we want to know what percentile it is. Now, you kids need to understand what percentile means. Percentile doesn't mean who you beat. So percentile means all of this. This is your percentile. These are all the doggies you're fatter than. So she is a chubby Chihuahua because she's fatter than all these doggies. So what we're going to do is pop over to our calculator, use a little normal CDF. So menu 552. I had a button on my thing. For that. Menu 552. Now your calculator probably doesn't come up with a negative infinity. It probably looks like negative 9e to the 99999. If it doesn't, you can just put a whole bunch of negative 9s in there. That's like saying negative forever. Now this chubby Chihuahua is 4,300 300 pounds. The average chubby Chihuahua is 3,080 pounds with a standard deviation of 550 grams. Not pounds, grams. So, lower bound is negative infinity. Upper bound is the weight of the dog. The mean and the standard deviation of population. We click OK, click OK. 0.988. I'm going to write this down because there's another tricky part to this problem. So I get 0.98672. 67288. Now, if you're not paying attention, you might circle this right away. That would be the probability rounded to the nearest hundredth. That is not the percentile rounded to the nearest hundredth, so don't fall for that. Okay? Now, it should be pretty obvious then it's choice 3. But remember, look what I'm going to do. I'm going to move it over here. And I want to round it to the nearest hundredth of a percent. So 98.67%. Chubby Chihuahua. The probability that Mr. DeVos pitches in any random game is 0.23. They have a game tomorrow, and the weatherman said the probability of rain is 0.25. Based on some very technical and tedious calculations that's way beyond you and me, it has been determined that the probability that Devo pitches and it rains is 5.75%. It can be concluded that the two events are. Well, rain and, mutually exclusive means if you had an and, if a mutually exclusive like Devos and rain would have to equal 0, and that's just not happening. Complements would mean they'd have to add up to 1, and complement means rain and not rain, not pitch and rain. Those can't be complements. They might luck into being adding up to 1, but they certainly aren't complements of each other. So what we really need to do is test for independence. If we can prove independence, then they're independent. If we can't prove independence, then we fall back to dependent. And the real quick test for independence is the probability of Devos and rain is equal to the probability of Devos times the probability of rain. Now, if this is true, I'm not saying it's true. I'm saying if it's true, then they're independent. If it's not true, they're dependent. So let's do some math. I'm going to do 0.23. You got to turn to decimals. 0.23. Oh, squeeze me. Probability of Devos is 0.23. The probability of rain is 0.25. And we want to see if it's equal to the probability of Devos and rain, which is 0.0575. Not looking too promising here, kid. Let's go. So 0.23 times 0.25. 0.0575. Oh, so it is in fact equal. So this is in fact equal, therefore they are independent. If I would have ended up with 0.0575 equals 0.4, not independent. They would be dependent. All right, I'm not sure if all of this is going to come up or not. I'm not even sure if all of this is in the curriculum. You know, it's kind of tough to see with only 3 tests what exactly they're going to test. But since we kind of covered this, skewness is. So let's talk about skewness first. Hopefully you've already graphed these. Remember, skewness follows the little tiny skinny part, the tail. It's called the tail. So skewness follows the tail. So this would be skewed left. Therefore, this one would be skewed right. Notice how I put them on the left and the right? I was trying to trick you. Skewed right. This is our normal distribution, so this would be symmetric. Symmetric just kind of means that basically they're the same on the left and the right. Well, if I go here, basically they're the same on the left and the right. So, in fact, this is symmetric and this one is symmetric. All right, let's talk about rank of spread, where 1 is the most variable and 5 is the least variable. Well, 5 is this one. Least variable is the one that's got all the data centered right here in the middle. Big, huge chunk right in the middle. The normal distribution curve will always be, not always, but for the most part, be the least variable. The one that's got the stuff so far away from the middle, like this one, is the most variable, ranking 1. This one's kind of all over the place, so this would be a ranking 2. And actually, these two tie for third. Basically, they're just mirror images of each other, so they tie for third. Now, the other thing I asked you to do, which I know is in the curriculum, is put a line for mean and for median. So I'm going to do the mean in green. So because we have a tail here, the mean follows the tail. So the mean for this one will be off here to the left. maybe not this far off to the left. And the median will be right about in the middle, median. So if I bring that over here, the median will be in the middle. And the mean gets pulled towards the tail. You got to remember that. The mean gets pulled towards the tail. For these distributions, the mean and median will be right in the middle. So if they're going to ask you, they're going to ask you one of these things. And the key thing to remember is the mean gets pulled towards the tail. It's like the tail walking the mean. No, okay, that has nothing to do with anything. But remember, the mean gets pulled towards the tail. 17, we're almost halfway through. This is awesome. The senior class was asked what they wanted to do as a senior prank next year. They were able to take a survey of the 300 seniors. 120 of them wanted toilet paper the administrator's car, so probability of toilet paper. Anytime you can bring toilet paper or farting into a math problem, it just brings like levity to a very stressful situation. And everybody likes toilet paper and farting, so yeah, so got to add it in. 120 over 300. So the probability, what's the other prank? Wanted to fill the cafeteria with balloons filled with glitter, so the probability of balloons is equal to 200 over 300. Now notice I'm leaving them still over 300. I'm not reducing them because that helps with adding and subtracting later. The probability that they choose toilet paper, oh, there it is, let me highlight it, big star, over. It is the word or, and any time you see the word or, immediately just start writing probability of toilet paper or balloons is equal to the probability of toilet paper plus the probability of balloons minus the probability of toilet paper and balloons. And the question is, how many students voted for both? So we're looking for this. And we have the other three pieces. We really just needed that formula. So here's what we go. Probability of this one is 275 over 300 is equal to the probability of toilet paper, which is 120 over 300, plus 200, that would be a 2, over 300, minus the thing we just don't know, toilet paper and balloons. Well, if I add these two up, I have no idea what I get. I'm going to guess you get 320. That it? Oh, so 275 over 300 is equal to 320. This is a 200, right? This is what's bothering me. That's a 200, right? Yeah. So 320 over 300 minus the probability of toilet paper and balloons. Getting kind of ugly here. Subtract this, and I get 275 minus 320 is 20, what is that, 45? My brain is shot, kids, completely shot. 275 minus 320. And if you're a teacher, don't judge. Because you know, you've been there, where your brain's just shot, it's not functioning, and the simple stuff's going hard. So negative 45 over 300 is equal to the probability, is equal to the negative probability. You can't have a negative probability of toilet paper and balloons. But since they're both negative, I can divide both sides by negative, and there be my answer. Nicholas Lang surveyed 240 people. And let's just add the word surveyed in there because that was like cool. About their favorite pizza, type of pizza. Complete the following Venn diagram based on the information. Now it says complete the following Venn diagram. So you got to complete it. Then answer the question. So 240 people were surveyed. Now this is the most specific. 720 of them liked garlic. So I could say, oh, okay, 7/20. How many is that out of 240? So I just cross multiply. What's that, times, man, my brain is not working. 12? Was this 84? I believe it's 84. I better check. Brain's not functioning right. 240 times 7, enter, divided by 20. 84, good. All right, so careful here. Careful, the probability of garlic is 84. I don't know anything else other than the probability that garlic. That means there needs to be 84 people in that one. So we're done with this hint. the probability of pepperoni given garlic. Now remember, garlic is now my new universe. The only thing I'm allowed to think about is this garlic circle right here. And how many people belong in that garlic circle? That would be 84. So my new universe is 84. So my denominator is 84. My numerator is, we'll call it P for pepperoni. Cross multiply, I get 3P equals S, that's 84. So P equals 28. Now 28 is the pepperoni part of garlic. So 28 goes here. And 56 got to go here. So we're getting there. Got it half figured out. Now, the probability of garlic given pepperoni. So now the only thing I'm allowed to look at, don't want to use that color, is the pepperoni circle. Well, I don't know how many people are in the pepperoni circle. I have no idea how many people are in the pepperoni circle. But I do know that 28 are garlic from the pepperoni circle. So this 2 sevens is equal to 28 over the entire pepperoni thing, which I don't know. So we'll call that, y. So 2y equals 28 times 7 is not going to happen in my head today. 196. Divided by 2, and we get 98. So there should be 98 in the pepperoni circle, but there's already 28 there. That means there's 70 left. Now, I'm not done with the Venn diagram yet, because there's still people that don't like garlic or pepperoni, and they got to go out here. So I'm going to take the 240. I'm going to subtract off the 70 that just like pepperoni. I'm going to subtract off the 28 that like both. And I'm going to subtract off the 56 that like just. Now notice I did not use these numbers, because these numbers include this number twice. So you don't want to use that one. I just subtracted these things off. So, and I get 86. So that means there were 86 people that were surveyed that don't like either of those two choices. All right, so what's the probability of garlic? That would be 84 out of 240. The probability of or is all of these. So let's see, I'm not doing it. 70 plus 28 plus 56. 154 out of 240. And finally, what's the probability of not garlic or garlic complement and not pepperoni? So they don't like garlic and they don't like pepperoni. Well, that's where you needed the 86. The 86 out of 240. I felt like I said we were halfway almost like 10 minutes ago, and we're still not even really halfway, so we got a long way to go. Let's get started. F of 35. Let's see if I wrote this right. So what we're going to do is we're going to plug that in for x. I probably should have said f of x. Oh, I did. F of x. Okay. So we're plugging that in for 35. So f of 35 is equal to negative 1/5 times 35. Now you got to be careful of order of operations here, kids. 3/2. This is not as easy as it appears. Although for some of you are like scared as heck because it looks really scary. It's not. Negative 1 minus 35 squared. Now, order of operations says we take care of what's inside the parentheses first. So, this is equal to negative 7. I'm just going to do that part out there. But now I got to be careful. What I'm trying to say is I don't do this squared. This is really negative 36. Let's just do this in pieces. 3/2 a square roots of negative 36 squared. Now be careful. I still got to take care of what's on the inside here. So, what is the square root of negative 36? That's 6i. So let's move over here. Negative 7 times 3/2 a times 6i squared. I'm still not ready yet because I haven't finished cleaning up the inside yet, so let's do negative 7. And don't you dare distribute that negative 7 before you square things. That's a mandatory must. Just keep it coming along for the ride. 3/2 times 6 is 9, so this is 9ai squared. Now everything on the inside gets squared, so negative 7 times 9 squared is 81. A squared, I squared. But, as everybody knows, I squared is really negative 1, so I will do that. Now I got to go to my calculator. Seven times 81. I'm not going to bother with the negatives because they're both negative. 567 A squared. How'd you do? All right, this is number 20. And then we're halfway. And now we got the hard problems coming. Woo! All right, this is going to be a long video. All right, so, oh man, this one's tough. Tough, tough, tough. Okay, remember, roots are in the ground. These are exponents. So this becomes 8x to the 6th raised to the 4/5 power equals y to the 8/5 power. Is this the one that's in simplest radical form? Yep. Let me highlight that so I don't forget it. All right. So what I'm going to do first, I think, is just get rid of this. And I'm going to raise it to the reciprocal, 5/8. Raise it to the reciprocal, 5/8. Well, here the 5's cancel, and the 8's cancel. I end up with y equals. Now here the 5's cancel, and 4 divided by 8 is 1/2. So this becomes 8x to the 6th to the 1/2 power. Okay. But 1/2 power, doesn't that mean square root? That's why it's saying radical. So y equals the square root of 8x to the 6th. Now I'm going to simplify it. Remember, we're looking for groups of 2. So square root of 4 times 2 times x to the 6th. Square root of 4 is 2. The square root of x to the 6th is x cubed. So my final answer is 2x cubed square roots of 2. Square roots of 2. There it is, kids. Winner, winner. Chicken dinner. Miss Jo Dozier, who just turned 16, didn't know it, but she has a really rich great uncle that passed and wanted to make sure she has forgot the dollar sign, $100,000 when she turns 50. The company he hired to make sure this happened promised to invest the money in an account that compounds the money continuously. Anytime it's compounding continuously, that's e to the RT. So if they can find an account that returns 3.7%, how much will they have to deposit? How much would they have to deposit? Round your answer to the nearest, $100. That's tricky. So we want to end up with $100,000. It's actually a very easy question. We don't know what our principal amount is, but because it's compounding continuously, it's e to the RT. Well, the R is 0.037, and the T, 50. Now, it's not 50 because she's 16, right? It's 34, right? Because it's 34 years. Careful with that one. So all I got to do is solve for P, which really means, since this is just a number, I'm going to divide by e to the 0.037 times 34. So I told you it was an easy question. Didn't believe me, did you? 100,000. Let's do it this way. Control division divided by e to the 0.037 times 34. So they got to deposit $28,000. God bless it. $422. And rounded the hundredths is 19. Oh. You mean they said $100, not hundredths dollars? Oh. So P really equals $28,400. Careful, kids, careful. If they deposited $20,000, what interest rate? So now we're saying, okay, we're really only going to be able to deposit $20,000. What interest rate would I have to have in order to still get that $100,000? So 100,000 is equal to 20,000 e to the r times 34. See, now I don't know r. Get the weird thing alone. Divide by 20,000. So I get 5 is equal to e to the 34r. That's a 34. Leave me alone. Anytime you have an exponential and you want to solve it, you have to use logs. In this case, you have to use the natural log, base e, but you know you're not going to be able to put that in because you can't put e in, of 5 is equal to 34r. So I'm going to, and then divide by 34. So notice when I put natural log in, there's no place to put a base because it's understood that it's e. So log base, natural log of 5 divided by 34. Oops. I hate when the calculator does that. And you get 0.047. I'm going to write it down. R equals 0.047336. Now you got to be careful. What does it ask for? The nearest hundredth of a percent. See, I got to turn this into a percent first. Once, twice. So it's 4.73%. And that would be the answer. So this is kind of a true story. My mother-in-law in Germany is definitely going through chemotherapy. I don't know what drug they're using, but I made up one. This is a drug they do use to use as chemotherapy. And this is its half-life, I believe. Has a half-life of 1.78 hours. My mother-in-law was administered a dose of 500 milligrams. How many milligrams to the nearest hundredths will there be after 3 hours? Okay. So you got to know how to do half-life formulas. So amount of the drug over time, the amount over time is equal to my start amount, which was 500. Half-lives always are 1/2 as your base. Now the exponent's kind of tricky. It's always a fraction where this is the every. Every hour it's a half-life. Every 10 hours, every 20 hours. In this case, every 1.78 hours. So the every for the half-life goes there. Every whatever the half is. And then we want it for 3. So that's all I got to do. Come over to my calculator. 500. Parenthesis, a half. Parenthesis, raised to the 3 divided by 1.78. So make sure it looks right. It'll fix it for you. 155.459. 155.459074. Now we want to round it to the nearest hundredths, so it's equal to 155.46 milligrams. All right. The doctor told her she will begin to feel better when the drug falls below 500 or 50 milligrams. How many hours, rounded to the nearest tenth of an hour, will she have to wait? Okay, so we're going to take 550. That's our A of t this time, is equal to 500, 1/2 t over 1.78. This time I don't know t. Now since I don't know t and it's an exponent, you ought to be able to say in your head, oh yeah, gonna have to use logs. Divide by 500, get the weird thing alone. Do not multiply that 500, that's just embarrassing. So that's what, 1/10? So 1/10 is equal to 1/2 to the t over 1.78. And if you want, you can just write this as 0.1, make it look nicer. All right, now because it's an exponential, I have to solve it using log. So log, it's all about that base, 1/2. And now these two things switch, of 0.1 is equal to t over 1.78. Now in order to get rid of that 1.78, all we're going to do is multiply this side by 1.78, and I'm going to multiply this side by 1.78. So I get t equals 1.78 parentheses log of 1 divided by 2 of 0.1. And I get 5.913 5.91303. So round to the nearest tenth of an hour. T equals 5.9 hours. Oh my. All right, so I'm going to do this. I'm going to start this, and then I'm going to come back to it. So I want to solve this system of equations algebraically. Before you do this, please use your linear systems of equations that you can solve. Whether or not you have to use matrices or what, but use it. X equals, Y equals, and Z equals. Use your calculator as a tool to make sure that you can get these right. Otherwise, you may be a tool. So, I'm trying to get it so I can see them. So I'm going to type them in. All right, so menu, solve a system algebra, solve a system of equations, and solve a system of linear equations. I've got 3 equations, and it's x, y, and z. Click OK. And I'm going to type them in exactly as they appear. 2x minus 4y, checking to make sure that you get them in right, plus 5z. One tall tale sign that you didn't get them in right is you got some crazy answers. If you got crazy answers, there's a good chance you're wrong. 6x plus 3y minus 2z equals negative 5. And finally, negative 4 minus y plus 3z equals, man, I did not make this easy, negative 3. Enter. See, those are crazy answers. Cray. So I must have made a mistake somewhere. And I didn't do it on purpose, I'll tell you that much. So I got to find it. 2x minus 4y plus 5z equals negative 40. That appears to be right. 6x plus 3y minus 2z equals negative 5. And I'm getting nervous because it looks right. Oh, there it is. Negative 4x minus y plus 3z equals negative 3. Ah, much nicer answers. One weird one, but the other ones, they're not this weird, right? They're not crazy. They're not crazy like these are, right? They're just a little weird. So, x equals negative 7 over 2. Y equals 2, and z equals negative 5. Now I'm going to pause for a second. I'm going to come back, and then we're going to do this algebraically. Man, these are long. All right, kids. Let's do this. I'm going to size them up a little bit. Doesn't look like any one of them's any real easier than the other. So I'm just going to I'm going to get rid of x. Doesn't really matter. So what I'm going to do is I'm going to multiply this one just by negative 3. So I get negative 6x plus 12y minus, be careful now, minus 15 equals 120. Minus 15z. And then positive 6x plus 3y minus 2z equals negative 5. We're going to add. When I add, these cancel. And I get 15y minus 17. What the heck is that? 17z equals 115. All right, so now I'm going to put these two together. I'm going to put the other two together. This one's not quite as easy. So I'm going to multiply this one by 6 and this one by 4. Because that'll give me 24. I know I could do it by 3 and 2 and stuff like that, but I'm going to do it this way. I just like interchanging the numbers. I think it makes it easier. So we're going to do 24x plus 12y minus 8z equals negative 20. And negative 24, notice the x's are going to go now, minus 6y plus 18z equals negative 18. Add them up. These go. I get 6y plus 10z equals negative 38. And that one I got to put together with this. So now I'm going to put that together. This is not looking good. I feel like I made a mistake. I feel like I might be going back and erasing and pretending I didn't make a mistake when I actually did. All right, let's see. So what I'm going to do is I'm going to multiply this one by 6 and this one by negative 15, because that'll give me matching pairs here. The matching pairs on the y, and so in effect I'm solving for z, and I'm hoping to get 5. I'm hoping I can come over here and check mark 5. So let's see, 6 times 15 is 90y minus, 6 times 17 I just don't want to do. 102 equals 690. Negative 90y minus 150z equals 570. 570 is positive. Add them up. These go away. 102 plus 15. 117. So negative 117 is equal to, this is not right. This is not right. This is not good. My feet stick out of, oh man, what did I do wrong? 690. Really would rather not start this over again. Where is my mistake? So I almost erased it all, and you guys probably saw it. The only thing I forgot was a 0 here. Ah, my goodness. I would have erased all that work and started over, and all I missed was a 0 here. But I knew I didn't have the right answer because I wasn't going to arrive at negative 5. So this is really negative 252 is equal to 0, 6, carry the 1, 6, 12, 1260 z. So if I take 1260, I think I already did it. 1260 and divide by 252, I get negative 5. So z equals negative 5. Done. All right, now what I'm going to do is I'm going to take this equation, 15y minus 17 times negative 5, and that equals 115. 17 times 5 is 85. That's positive 85. So 15y equals plus 85 equals 115. Subtract 85, I get 15y equals, what's that, 30? Or y equals 2. Ka-ching. And finally, I'm just going to copy over the most positive equation. That's this one. So 6x plus 3 times 2, 3y, minus 2 times negative 5 equals negative 5. Let's see. This is 6x plus 5 plus 10 equals negative 5. Add 15. I get 6x is equal to, this is a 6, by the way. So 16 and 5, I'm going to add 16. What does that give me? I have no idea what I'm just doing. Oh, all right. Let me show my work, because if I don't, I'm going to make a lot of mistakes today. 6x plus 6 minus, or plus 10 equals negative 5. 6x plus 16 equals negative 5. Subtract 16. I get 6x equals 21. Divide by 6. Divide by 6. Actually, it's negative 21. Notice I had negative up here, and it reminded me it's got to be negative down here. And if you reduce that, you get negative 7 over 2. Oh, my goodness. Sorry about that, kids. That should not have taken that long. All right, I'm getting tired. How about you? Get your second win or your second cup of coffee. This is still my first. All right. So what they're saying is that these 3 points satisfies this equation. So I'm going to plug them in. X and Y. So negative 21 equals A times negative 3 squared plus b times negative 3 plus c. Or in other words, negative 21 is equal to 9a minus 3b plus c. That's equation 1. Now I'm going to plug in the next one. 9 equals a times 3 squared plus b times 3 plus c. 9 equals 9a plus 3b plus c. There's my second equation. I'm hoping I haven't made a mistake, and I'm going to show you how we can test for that in a minute. Kids, I'm dying. Oh my goodness. I wish I had like somebody over here to help me. All right, so a times 5 squared plus b times 5 plus c. Or negative 13 is equal to 25a plus 5b plus c. Now, when you get to this point and you have your 3 equations, it's this time you type this stuff into your calculator. I'm going to pause it. I'll be right back with that stuff typed in. So I got them typed in. Let me press enter. Hopefully I get a nice... I did it again. Because those are ugly. There's no way those are right. There's no way those are right. And here it is. I already see it. I got 2 C's on this first one. So I'm going to guess this should be a B. Let's see if this works out nicer. Nope, still ugly. How can you make this many mistakes, Kraus? Negative 29 equals 9A minus... Oh, I got 6. How did I type in a 6? Why is it not a B? B. I'm just going to let you watch. I could pause it so you don't have to watch me go crazy, but I'm not. Negative 21 equals 9A minus 3B plus C. 9 equals 9A plus 3B plus C. Negative 13 equals 25A minus 5B. Jeez. Sometimes it's just easier just to start over. Negative 2, 5, and 12. So A equals negative 2, B equals 5, C equals 12, and what we think is our answer is negative 2x squared plus 5x plus 12. Now I said I have a foolproof way of knowing if that's 100% correct, and that comes just from quickly graphing it. So we'll go into our graphing calculator, graph this thing. So negative 2x squared plus 5x plus 12. Press enter, and don't overthink this. Just go to the table. And we're looking for those 3 points. Looking for those 3 points. So, I'm looking for negative 3, negative 21. There it is. I'm looking for 3, 9. There it is. And I'm looking for 5, negative 13. There it is. So I know for 100% that's the right answer. But I'm probably only got 2 points out of 4 on this right now. I got the equations, maybe only 1, because it does say solve algebraically. So I got to do some work. So I'm going to put these 2 together. Now when I do that, I'm going to get rid of C. So I'm going to recopy. I'm going to copy over the first equation. Hopefully not making any more mistakes. And I'm going to multiply this equation by negative 1. And you'll see why I do that in a minute. I always get rid of C on these kinds of questions. It makes, the A's are going to go too. It makes your life so much easier. And that was just dumb luck that the A's are going too. A's go and C's go. So I end up with negative 30 equals negative 6B, or B equals 5. I already got one. That's nice. Now we're going to do the same thing, but we're going to do it with these 2 equations. So I copy over the green equation, negative 13 equals 25A plus 5B plus C. And that same negated equation that I used earlier, negative 9 equals negative 9A minus 3B plus, minus C. Notice C goes away again. So I get negative 22 equals 16A plus 2B, and the C's go. But I already know what B is, so I can just plug that in. Negative 22 is equal to 16A plus 2 times 5. That's 10, so I'm going to subtract 10. So I get negative 32 is equal to 16A, or A is equal to negative 2. Ka-ching! Now I'm going to take the most positive equation, which is the second one, the blue one. I'll do it in blue even. So I go 9 equals 9 times negative 2. That's A. Plus 3 times B, which is 5, plus C, which we don't know. So 9 is equal to negative 18 plus 15 plus C. That's negative 3, so I'm going to add 3 to both sides, and I get 12 equals C. So there's my equation. I still have a part B here. Part B says algebraically determine the roots. In other words, negative 2x squared plus 5x plus 12 equals 0. Now, I don't like factoring when this thing's negative, so I'm going to move everything to this side. So I get 0 equals 2x squared minus 5x minus 12 equals 0. I could factor this, or I can use menu 331 on my calculator. If you haven't seen that, you just go over here. And you go menu 331. Algebra. It's 331 for you guys. Factor. No, it's solve. Oh, it's polytools. Polytools. It's 331 on the other one. And find the roots of the polynomial. Second degree polynomial. 2, -5, -12. And it tells you the answers, but I could have just factored it. 2x and x minus, what was that, -3, so it's +3, and -4. Now that's -8 plus 3 is -5, so this gives me x equals -3/2, and x equals 4. It's a lot of work, kids. All right, here we go. I'm going to do my best. There's like a 0 chance I'm going to write this neatly on this. So let me get my axes on there. I want to, it doesn't say what I got to do, but I just got to graph 2 cycles. So I'm going to put my x-axis here. Told you, it's not going to look pretty. It's almost impossible to draw on this thing. And since my midline is +3, I'm going to put my x-axis a little bit lower. All right. So let's see what we got. We're going to do a sine curve. We'll talk about that. We got our period. Period is equal to 2 pi over 3. So I'm going to do my x scale now. My x scale is 2 pi over 3. Now we divide by 4, and I'm going to show you why. Divide by 4. Dividing by 4 is the same as multiplying by 1/4. So I get 2 pi over 12, or pi over 6. Now the reason I do 4 is because I always use 4 points. I always graph 5 points. I need 4 more. And I'm going to count by pi over 6. Pi over 6. 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. And notice I end up at 2 pi over 3, which is my period. So in those 4 tick marks, I should graph one full sine curve. Okay, let's get ready to rock. My midline is y equals 3. Oops, I need a scale on the y-axis. 1, -1. So I need a midline on this one. All right, there it is. There's my midline. What do I know about a sine curve? A sine curve starts at 0. It ends at 0. Now it's 0 on the midline because we moved this thing up, and in the middle it's 0. So it starts at 0, ends at 0, 0 in the middle. Okay. Now the other information it gave us is it goes to the point pi over 2, 6. Let's see if that makes sense. Pi over 2, up, that's 3, 4, 5, 6. Now isn't the amplitude 3? Oh, okay, that makes sense then. It went up 3. That means in between here it should go down 3. 1, 2, 3. Ah, so that goes like this. Now it did say I have to graph this for 2 cycles, right? 1, 2, 3, oops. 1, 2, 3, 1, 2, 3, 1, 2, 3. Begins and ends at a 0. In the middle is a 0. In between those we'll go to a max and a min. There we go, kids. Moving on. Next one I think is a cosine curve. So this one, now this one they tell us we're going to graph from negative pi over 2 to pi over 2. That means I'm going to put my axes right in the middle. Now I am going to go look at my midline first before I put the x-axis in. The midline is up 2, so I'm going to put the x-axis a little bit lower. It doesn't have to be much lower. All right, so now we just got to start writing our information down. A equals 5. A does not equal -5. B equals 4. From B, I go right to period. Period is equal to 2 pi over 4, which is really pi over 2. Now I go to x scale. X scale is always period divided by 4. Pi over 2 divided by 4. But again, dividing by 4 is the same as multiplying by 1/4. So my x scale is pi over 8. So I'm going to count by pi over 8s. 1, 2, 3, pi over 8. 2 pi over 8, or pi over 4. 3 pi over 8. 4 pi over 8, or pi over 2. Oh, that's where they want me to stop. Now I'm going to do the same thing this way. I don't have to put the scale this way. You just got to be uniform. 1, 2, 3, 1, 2, 3, 1, 2, 3. I always use either 3 or 2 or 3. It doesn't matter. So we're going to graph it to the right first, and then I'm going to carry it over to the left. Let's see how that works. Oh, I need my midline. So y equals 2 is my midline. So let's graph the midline in. Dot, 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 dot. Y equals 2. Now the difference between a cosine curve and a sine curve is a cosine curve starts at a 0 and ends at a 0. Oh, excuse me. Cosine curve starts at a min. Cosine curve starts at a min and ends at a min, or starts at a max and ends at a max. Not starting on the midline. We're not going to start on the midline. So, because this is negative, I'm going to start on a min. And I'm going to go down 5 from here. 1, 2, 3, 4, 5. I'm going to start at a min. I'm going to end at a min. In between the mins is a max. So halfway in between is a max. 1, 2, 3, 4, 5. In between those are zeros. On the midline, zeros. Don't go back to the x-axis. And don't count your 5 up and 5 down from the x-axis. You count from the midline. That's why the midline is so important. So, graph this sucker. And now, begins at a 0, or begins at a max, min, ends at a min. In the middle is a max. 1, 2, 3, 4, 5. In between those, on the midlines, are zeros. And there it is, from negative pi over 2 to pi over 2. I had no idea this was going to take this long. Oh, my mouth hurts, actually. Yep, long story. Let's go through this thing. Jordan bought a car that originally cost $4,500, but she got a gift of $5,000 that she's going to use as a down payment. So she's going to have to borrow $40,000. The number of payments, she's going to do it for 5 years. Some are monthly payments. 5 times 12 is 60. We don't know this. And our interest rate is 3.5% yearly interest rate. That's not, well, that's not. So in order to find monthly, we're going to have to do 0.035 and divide by 12. Notice month and year. All right, we're ready to go. 40,000 is equal to my payment. Let's start filling crap in. 1 minus 1 plus 0.035 divided by 12 to the negative 60 over 0.035 divided by 12. So 40,000. Make sure you don't hit too many zeros. 40,000 divided by controlled. Oh wait, hold on. Sorry. Let me do it the right way. So 1 control division. 1 minus parenthesis 1 plus control division. Make sure that you get this in there right. 0.035 over 12, all raised to the negative 60, all over control division. 0.035 over 12. Whew. Make sure it's in there right. Make sure it looks perfect. Press enter. You get some odd decimal. This is not your final answer, so don't you dare round it. 40,000 is equal to our payment. Write it all. Don't be lazy. 54.96999699 514. So then I'm going to take 40,000 And I'm going to divide it by, and don't retype that in. Hit the up arrow, highlight it, and press enter. Let it type it for you. That way you don't make a mistake. $727. So my $727, and this is my answer, so I'm going to round it. And 67 cents. If you're off by a penny, you lose 25% on this problem. I know that sucks, so you have to pay attention to detail. If she can only come up with a monthly payment of $550 but still wants to use her $5,000 down payment, what's the highest price vehicle she can purchase? So we don't know what she can buy, but we know she can come up with $550. Now, the cool thing is I've already done all this math. It's here. So I just got to put 5496998785514 and multiply by 550. There's a little bit more to do than that, but 550 times, go find it, don't retype it, 30,233 $30,233, and I'm having a hard time going, 49 cents. But that's what she can afford monthly payments wise. I need to figure out what she can actually afford. So to that, I'm going to add the $5,000 that she can use as a down payment. So I get the amount she can afford is $35,233.49. All right. Now, this by the way would be a 6-point question. She still wants to buy that $45,000 car. She just has to have that $45,000 car. So she still has her $5,000 to payment. She can only make $500 a month. So we need to figure out what term loan she can get. And I guess I should have said it's still at 3.5%. So we're going to take $40,000. That's what we can buy. Our monthly payment's going to be $550. And this is going to now change. 1 minus, I always forget if that's minus or plus. 1 minus 1 plus 0.035 over 12 to the negative n, because this time I don't know what n is. All over 0.035 over 12. Now this one's going to require some work. First thing we got to do is get the weird thing alone. We're going to divide by this. So 40,000 divided by 550, and leave it like this, 800 over 11, that's fine. All over 0.035 over 12. So now what I'm going to do is I'm going to multiply this side by this denominator, 0.035 over 12. And this side by the same thing, 0.035 over 12. Because what will happen is on this side they just cancel. And I got it over here. So I can just take this, I'm going to multiply by control division, 0.035 over 12. Boom. 0.21 repeating. So I get 0.21 repeating is equal to 1 minus, it's getting simpler, 1 plus 0.035 over 12 to the negative n. This problem itself is like a 6-point question. Subtract 1. And I get negative 0.78 repeating. Negative 0.78 repeating is equal to negative 1 plus 0.035 over 12 to the negative n. But since they're both negative, I don't need those. All right, kids, now the moment of truth. We have an exponential. In order to solve an exponential, you need to use log. So log of this crazy base right here, 1 plus 0.035 over 12 of 0.78 repeating is equal to negative n. Are you kidding me? So control log of 1 plus .035 divided by 12 of the answer, control answer, and I get okay, I gotta get rid of that negative. Remember we got rid of the negative? There it is. So negative 81.86. So negative n equals negative 81.86, or n equals 80, looks like 82 months, right? But, of course, I didn't stop there. I said to the nearest year. To the nearest year. And the year would be 7 years, because if you divide by 12, you get 7 years. So 7 years is the answer. All right. That problem took like an hour. It actually took 8 minutes. All right, here we go. Events X and Y such that probability of X... Oh, I see an OR. As soon as I see an OR, I'm going to write my OR formula. Probability of X or Y is equal to the probability of X plus the probability of Y minus the probability of X and Y. Determine if the events are independent or dependent. So, my test for independence, my simple test for independence would be this. Probability of X and Y is equal to the probability of X times the probability of Y. So I'm going to use this idea and I'm going to test it this way. I know this is 0.86. I know this, probability of X is 0.65 plus the probability of Y is 0.43. Now, I don't know this, but I'm going to use this idea and I'm going to see if it's independent. I don't know if it's independent, but I'm going to see. So 0.65 times 0.43. If this turns out to be equal, then they're independent. If it turns out to be not equal, I shouldn't have done this because they're dependent. So, come over to my calculator. 0.65 plus 0.43 minus 0.65 times 0.43. 0.8005. So does 0.86 equal 0.8005? No. So they are dependent. The Scarpula organization has been actively recruiting young ladies to join their cheer teams. They told the prospects that 38.1% of girls dance, 75.4% of them take gymnastics, and 23.8% take both. Find the probability to the nearest thousands that a cheerleader is in dance given that they take gymnastics class. Whoa. So probability of dance is equal to 0.318. The probability of gymnastics is equal to 0.238. And the probability of both dance and gymnastics is equal to 0.23. No. This one's not right. 0.754. All right. So I didn't say they're independent. I didn't say an or. I didn't say anything. So you got to assume that they're dependent and use the dependent formula. And the dependent formula is the probability of dance and gymnastics is equal to the probability of something times the probability of something with a given. Well, that's what I'm asking for. So I want dance given gymnastics. So that's what's got to go here. So that means gymnastics has to go here because this should be your independence formula. And it is. So pop these things in and we're done. 0.238 is equal to 0.754 times the probability of dance given gymnastics. So 0.234 divided by 0.754, and I get 0.310 to the thousandths place. So the probability of dance given gymnastics is equal to 0.310. Explain to a prospective family what your answer in part A means. So in order to bear with you, I'm just going to tell you, and you can like not have to watch my poor penmanship. There is a 31% chance that a girl that is in gymnastics, already in gymnastics, also takes dance. So there's a 31% chance a girl selected at random from the gymnastics class also takes dance. That's what it means. All right. Oh, good. We got some easy ones. Oh, so this first one's not too easy. So it's 2x squared minus 9x plus 27 equals 0. Now, I knew I was going to have to do that because I can't use completing the square. So I have to resort to my quadratic formula. A equals 2, B equals negative 9, C equals positive 27. Now, D squared is going to be 81, which is B squared, minus 4 times 2 times 27. If I'm not mistaken, I think this is 135. 81 minus 4 times 2 times 27. I think it's actually negative 135. Yeah, it's negative 135. Now, I knew it was going to be negative because it wants an imaginary. So I'm almost done. X equals negative B, which is 9, over 2A times 2, plus or minus the square root of negative 135 over 4, really. So I get X equals 9 over 4 plus or minus. Now, this thing I got to work on. I think it's 9 goes in there. Yep, 9 times 15. So negative 9 times 15. Square root of negative 9 is really 3i. So my answer is 3i square roots of 15 over 4. Now this next one could be done that way, but I think actually the easiest way to do it is first use completing the square. So we're going to divide by 3, and divide by 3. So I get x squared plus 16x plus 80 equals 0. Because this is still even in the middle, I can use complete the square. So x squared plus 16x plus square equals negative 80 plus square. Now what goes in this square? Half the middle squared. So what is half the middle? X plus 8 squared is 64. So I'm going to add 64. So this is equal to negative 16. Almost done. Take the square root of both sides. When you take the square root, don't forget to put a plus or minus. So I get x plus 8 equals plus or minus. Now what is the square root of negative 16? Come on, come on, come on. It's 4i. So I get x equals negative 8 plus or minus 4i. Notice I just brought the negative 8 over and put it out front. All right, kids. Oh my gosh, we're already an hour and a half in. If you're watching this whole thing, you are a trooper. Let me ask you a question. If you had 3 to the x equals 3 to the 5, wouldn't you just say x is 5? Of course you would. And it doesn't matter if you had 3, 2. As long as the bases are the same, we just have to make sure the exponents are equal to each other. So whenever you have a problem like this, we just want to make sure those bases are the same. So instead of 27, it will be 3 cubed to the 2x squared minus x minus 2. And on this side, 81, believe it or not, is 3 to the 4th. That's a 4 to the x squared minus 1. Well, once I have that, now all I got to do is set the exponents equal to each other. And remember, that's a 4, not a 9. So 3 times 2x squared minus x minus 2 is equal to 4 times x squared minus 1. And that's now my new equation I need to solve. 6x squared minus 3x minus 6 is equal to 4x squared minus 4. Set it equal to 0. So 2x squared minus 3x minus 2 is equal to 0. 2x and x minus 2, and plus 1. So I get x equals negative 1/2 and x equals 2. Now you should check them, but I'm pretty sure they both work. And I'm really tired, so I'm going to keep going. Radicals I'm definitely checking because I know those often have problems. So first things first, get the weird thing alone. X plus 14 equals x plus 2. Square both sides. And I get x plus 14 equals x squared plus 4x plus 4. All right, we're going to solve it. So we're going to bring everything to the left side. And I get 0 is equal to x squared plus 3x minus 10. Factoring is pretty simple. X plus 5, x minus 2. So I get two answers. X equals negative 5 and x equals 2. When you check this one, and I'm going to save myself some time, negative 5 doesn't work. It's not always the negative, but in this case, negative 5 does not work. All right, same thing here. We're going to get the weird thing alone. We've got to bring the 2x over. Why, oh, why will you not move for me? So we're going to bring that 2x over, so I get the square root of x squared plus 5x minus 23 equals 2x minus 7. This was a little bit different, more difficult, square and square. So I get x squared plus 5x minus 23 equals 4x squared minus 28x plus 49. Bring everything to the left side, to the right side. 3x squared minus 33x plus 72. What I notice about those is, and that's why I was just hesitating, a 3 goes into all of them, so I can take a 3 out, make my life even easier. X squared minus 11x plus 24. I got simple factoring. X minus 3, x minus 8. So my two answers are x equals 3 and x equals 8. I will check these just to show you one check on these. So got to grab my graphing calculator. And let's go 8 control var x. Generally one of these doesn't work. So square root of x squared. Now, always don't be that tool that doesn't do this. You check back in the original. And donuts, what I'm about to eat. Don't use the equal sign. I assume you can tell if it's equal to 6, 7 if not. Or not. X squared plus 5x minus 23 minus 2x. Negative 7, negative 7. Now I'm going to try 3. So 3, control var x, press enter. And, oh, negative 5. Oh, so the answer is just 8. Man, those even look bad. All right, the length of time it takes to complete the New York State Civil Service exam is approximately normally distributed with a mean time of 2.5 hours and a standard deviation of 18 minutes. Whoa. Did you notice? 2.5 hours. It's 120 plus 30 more. That's 150 minutes. Just checking because my brain's not working. 2.5 times 60, 150. Good. Only those that finish in 124 minutes or less get their test scored. 500 people took the test. So of course it's a normal distribution. And yes, I'm tired. So 150 is the average. Standard deviation of 18 minutes. Now, it's over here is 124, and that should come as no surprise because the faster you are, the shorter your time. So I need to figure out what percent of people are less than that. So I'm going to go to my calculator, menu. Why do I do menu? Menu 552. The low end is negative infinity, and you might have to put a whole bunch of negative 9s in there. Negative 9. No decimal point, just 124 150, and 18. Now remember, this is going to give me my percentage. So this is equal to 0.070 or 0.0743, so on and so forth, percent. But that's not part of the problem. It's 500 people. So I got to take this and multiply by 500. And that will tell me how many people are going to get their test scored. 37.15. By the way, that's not at all how it works, but I thought I'd tell you that. Miss DeStemino felt her SAT score was better than Miss Hughes's score on the math part of the ACT. Math. So, since you can't compare one distribution with the other, the only way to compare one distribution with the other distribution is to compare z-scores. So we're going to do DeStefano, call it Dis, and we're going to check out her z-score. Well, she got a 700. Remember, it's x minus mu over standard deviation. So x minus, what's the mu? 500. 505 over the standard deviation of 85. And then we're going to come over here to Hughes, baby Huey. And we're going to do a z-score here of, what'd she get? She got, I know she got a 31. There it is. Couldn't find it. She got a 31 minus 20.6 all over 3.8. So we're going to compare what their two z-scores are. So I need to go to my calculator. Control division. Make sure you always use control division when you're doing this so you don't make a silly mistake. 700 minus 505 all over 85. Her z-score is 2.294. And now we got to do hers, control division. 31 minus 20.6 all over 3.8. And she got 2.736. Because her z-score is higher, remember, z-score is how far away you are from the mean. So if it's the mean, the further away I am, the better I did. So Miss Hughes did better because her z-score is higher. All right, Dr. Morelli just created a new jug to reduce the stress of students in math class. What can she do to test this? All right, so I'm going to just walk you through this one. Number one, she's going to randomly select two groups of people. That's number one. Number two, well, first things first, she's going to create a controlled experiment. Create a controlled experiment. She's going to randomly select two groups of people. If you don't use the word random, it's wrong. So she's going to create a controlled experiment, randomly select two groups of people. One of the groups is going to get the treatment or the drug to reduce stress. One of them is going to get a placebo. And she's going to collect data and make some assumptions or analysis. That's it. 2 questions left. Ms. Zhang is currently studying to see if people would prefer to vacation in the United States or vacation in the United States or abroad. She was surprised to determine that 72% of people would prefer to vacation right here at home. In order to strengthen her findings, she conducted 1,000 more surveys of 300 people. Assuming a 95% confidence level, what is the margin of error? Margin of error is defined as Z star times standard deviation. Well, Z star for 95% is 2. So we got to just multiply by the standard deviation. So let's go find the standard deviation of the problem. It's not there. So you have to calculate the standard deviation. And the formula for a standard deviation for a proportion, this is a proportion. I know this is a proportion is because the only reason it's a proportion is because Ms. Zhang said, hey, do you prefer to stay in the United States or abroad? Or actually what she's saying is, do you prefer to stay in the United States? It's a yes-no kind of a question, or a two-tiered or two-part question. United States or abroad? United States or abroad? It's only 2 choices. It's not like 40, So it's a proportion. So in order to find the standard deviation for a proportion, it is equal to the square root of p times 1 minus p over n, square root of n. Now, not this. This is just how many times you did it. It was 300 people. So we're going to say, okay, 0.72 times 0.28. Now, where'd the 0.28 came from? That's 1 minus 0.72. They just have to add up to 1 all over 300. And this will give us our standard deviation. So that we need our calculator for. So the square root of a division of 0.72 times 0.28 all over 300. And I get 0.259, 0.0259, but I got to multiply that by 2. So 0.05. 0.052. There it is. And finally, last question. At the New York State Fair last year, 200 visitors were asked if they were visiting the fair primarily to see the animals or for the food. What they found was that 70% of the visitors were there to see the animals. The organizers had their employees ask different groups of people on different days. In total, they had 470 different samples, each of size 200. The approximately normally distribution of the data are shown below. It's approximately normally. Using the results graphed above, determine a plausible interval containing the middle 95% of the data. Round all answers to the nearest 10,000th place. Well, 95% again is 2 standard deviations, and they give all the information up there. So all we got to do is 0.702 plus or minus 2 of the standard deviations, 0.048. So 0.702 plus 2 times 0.048. So the high end is what hundredths place, right? 0.80. And this is 0.798. Let's just do the plus there, not the minus. And then we'll do the minus below. 0.702 minus 2 times 0.048. 0.61. 0.606. So the 95% confidence interval will be between 0.61 and 0.80 or 2. The New York State Parks and Recreation Department that oversees the New York State Fair, by the way, I have no idea if that's true, told the organizers that if they come and survey the visitors and find, if they come and survey the visitors and find that 58% or less of them are there for the animals, they may not provide 100% funding for the fair's year. Do the organizers have reason to worry? So let's find out we're about 0.58. Let's say 0.58 would be about here, right? So all of these are less than 0.58. So maybe they could come up with one of these. Maybe they can come up with one of those. But let's see how probable it is. So let's see. This is about, if I just take, all right, I'll take all those. So that's like 7, 8, 9, and 2 more make and 10. And that's 5, 10. So 9, that's like 19. So 19 out of how many of these distributions? Well, we did this 470 times. So 19 out of the 470. So 19 divided by 470 is equal to about 4%. Approximately, so about 4%. Do the organizers have reason to worry? No, I'm just going to say it. No, the organizers do not have reason to worry. The chance of them coming and getting a sample distribution that is 58% or less is only about 4%. The cutoff would be 5%. If it was more than 5%, then they have some reason to be worried. But they really don't have reason to worry because it's not very likely to happen. Boom. There's your answer. And that ends day 1. Thank goodness. Now I get to go do it again with a live audience up at school. Yay! All right, kids. Keep studying. Keep working. Hopefully this stuff helps. Tomorrow, I'm telling you, day 2 is even better than day 1. I was doing the answer key for day 2 today, and I was like, totally stoked. It was such a cool. So tomorrow's is even better. And then there's day 3. All right, guys. Catch you all on the flip side. Goodbye.